Okay, everyone, thank you for joining us for today's LF on the Edge with LF Edge webinar. Today's topic is Project Eve. We're going to be talking about building the Android of the IoT Edge. Before I introduce our panelists, just a couple of housekeeping updates. All of our attendees will be muted throughout the presentation. However, if you would like to ask a question, we do have a Q&A window that will be open the entire duration. We can address some of those questions via typed response on the window directly, and we've also reserved a few minutes at the end of the presentation for live Q&A. All right, so today's panelists, we want to go ahead and tick to the next slide. Today's speakers, we have Roman Shaposhnik. He's the co-founder and VP of Product and Strategy at ZEDEDA. We've got Jason Shepard. He's the VP of Ecosystem, also with ZEDEDA. And we have Stefano Stabolini. He's a principal engineer and tech lead at Xilinx, and he has actually been working with the Zen project for a number of years. So he brings that expertise into his work with Project Eve. So without further ado, I'm going to go ahead and kick things off to Jason to get us started.
All right, great. Thanks, Jill. So we'll start with kind of an overview of LF Edge and the purpose of the organization as an umbrella project within Linux Foundation. Today in Edge and in IoT and kind of broader use cases around that are involving edge computing, we're seeing a lot of siloed activity, lots and lots of platforms, a lot of really great things happening, including from the clouds. But it tends to be these siloed platforms. Even the history of kind of the industrial world has been these platform silos, and that can lead to issues with getting data locked into a given platform. You might get dark data in some cloud, kind of control issues between data in different applications and that underlying infrastructure. And it's kind of it tends to be very centric to applications that are locked into very specific hardware. And then so the whole point with LF Edge is helping drive through open source collaboration more of an open data architecture. There's projects within this umbrella that are both kind of more on the infrastructure side of the software element and more on the application side of the software side of things. But together, it's really about creating more of a universal abstraction layer for Edge and IoT and various different use cases, where you use the choice of cloud that you want to use, or choices, cloud strategy. You use the apps and domain experts that make sense to you, but you don't have to reinvent like those foundational plumbing elements. And so we think that this is a really good way to drive standardization around common frameworks, but still enabling people to go innovate where there's a lot of places to add value. So you can really focus. I mean, open source innovation is about minimizing undifferentiated heavy lifting, and that's Linux Foundation really comes into play and provides that governance, and the community is doing great work. Just much more software defined edge across the continuum. Next slide. So a couple key takeaways for LF Edge as an organization. So it's all about harmonizing the communities across various different markets. So there's IoT, of course, enterprise, industrial, the cloud players, the telcos out there, service providers. Just trying to provide as universal as possible of a framework, rooted in open source, but also, of course, you can't cover everything. That's where people build value on top, and we of course encourage that. It's all about, of course, open and then driving interoperability. But we're not playing favorites to hardware or the silicon underlying there. Any particular cloud operating system protocols. I mean, in IoT, there's hundreds, if not thousands, of protocols if you count all the proprietary ones, and it's just really, really fragmented. Everything gets more and more complex and fragmented the closer you get to the physical world as you span the continuum from the cloud, to the device edge. And so, it's all about being kind of agnostic to some of these technology choices, enabling choice, creating those APIs within the frameworks, and harmonizing those APIs increasingly over time. bringing in various different considerations from these different markets, working with other consortium efforts. So we're standards bodies and consortia like Industrial Internet Consortium, Automotive Edge Computing Consortium, Open Edge Computing. I mean, just a lot of great organizations doing work across the board. But by doing that kind of collaboration with open source at the core, you can really start to accelerate the pace of innovation on top and the standardization of those lower level frameworks. Because you can run code, you can and do new things and innovate and contribute on top of that. And so it's very similar to other open source communities within the Linux Foundation, like CNCF, where Kubernetes was born, and a lot of great stuff happening there. LF networking, ONAP was come out of that umbrella. And other organizations. So it's all about bringing together projects, being inclusive and welcoming, but there's also structure to how it's built. So if you go to the next slide. It's all about enabling a place for projects to incubate and grow, build up their governance model with Linux Foundation providing vendor neutrality. And so there's these different stages. This is a very similar model to some of the other umbrellas. And so EVE, which of course we'll talk about today, EVE is a stage 2 growth project. And then you've got the various other projects, and there's lots of detail on the website, and there's some other webinars as well. But basically the stages are related to the growth of that community, the adoption out in the field. It's a number of factors, and those are also available online should you be interested. One other thing I'd mention, just to kind of pay attention, for is there's a white paper that we're building out in the community that will be released probably early to mid-June, next few weeks, and we spent a lot of time as a community to create a taxonomy that really considers all of the different trade-offs between the different markets. If you look at edge taxonomies today, and there's a lot of edge taxonomies, a lot of people talking about different perspectives, they always tend to be focused towards one market, one point of view, whether it's a telco point of view, an IT point of view, an OT point of view, you name it, and consumer, you name it. And so what we've done is we've created a lowest common denominator set of language that takes into inherent technical trade-offs and logistical trade-offs as you span the continuum from the cloud to the device edge, and paper and and visuals and whatnot, and we lay these projects out along that spectrum. So stay tuned for that. EVE, just to kind of set it up, within that spectrum, a category of edge, a subcategory, where you're outside of a physically secure data center, so you're not locked up, inside of an on-prem data center or centralized. So you have security concerns, both physical security and network security. You might not own that network. You don't have a firewall in front of that device. So these are IoT, focused workloads outside of a secure data center, but then also compute devices that are still capable of running some level of abstraction. So we're calling categories. So the smart devices. So it's the same thing as mobile devices, PCs, and all that, and the kind of the user space fit into that category. They can run applications. You can run things on Android or etc. But in the IoT sense, with gateways, even ruggedized servers sitting outside of a data center, a secure data center, those are fitting into this kind of IoT edge subcomponent. So that's what EVE is focused on, is do for the IoT edge what Android did for mobile, and hence the title of the presentation. So a lot more detail in the white paper. Next slide. Okay, and then just kind of really quickly, Linux Foundation, more broadly speaking, of course, there's LF Edge that we're talking about today with EVE specifically, but then there's a lot of other projects within different umbrellas, and also those links to the various different consortia that I mentioned. It's all about kind of bringing together, let's come together where it doesn't matter to be different, where it helps us accelerate and focus our time on things that add value for our customers and for ourselves. So lots and lots of good stuff happening across the board. Next slide. Okay, so what's Project EVE? So again, it's think of EVE as doing for IoT, the IoT edge, what Android did for mobile. Create kind of like the one stack that you need for your edge hardware, because there's so many operating systems out there. There's so many different choices you need to make in terms of supporting legacy applications, maybe something that's been running on Windows for a long time, and you don't want to scrap that application, so you need to be able to virtualize that application, you consolidate workloads, but you want to run all the, a bunch of containers for kind of modern stuff. You want to comprehend Kubernetes and all that to the edge, and Roman, we'll talk about that a bit more as we evolve Eve. But Eve is we're calling it, it's like an edge compute engine, so to speak. It is in the infrastructure plane. It does not, it's not focused on applications. Projects like EdgeX Foundry and Fledge within LF Edge are completely complementary. You run on top, Azure IoT Edge, Greengrass, you name it, any kind of edge app, that you choose, your choice of AI models, etc. So Eve is all about that underlying foundation that would run on a piece of hardware out at the IoT, whether it's a gateway or a server or whatnot. But again, it's IoT Edge outside of a physically secure data center, still capable of running abstraction. And that means it has enough memory. So driven by memory, generally speaking, 256 megs of memory. That breaks you down into, you're going into constrained devices, and you no longer can support the overhead, but that also provides flexibility in or containers. And so Eve is all about that abstraction, and it's all about creating an open API that then your choice of controller can be used on top. So there's an open source basic controller, and then the whole point is that you can create that you can use a commercial controller of your choice, whatever you want. I mean, that's what ZEDEDA focuses on. But at the same time, it doesn't work if that foundation isn't 100% open, so that customers feel confident that they're not going to get locked into a given foundation or back end, following the same principle in terms of breaking down the silos that I talked about earlier. So it's all about simplifying development, orchestration, and security of cloud native apps at the edge. Roman will go into detail on the feeds, and it's just like, instead of having to have all these different OS that you might have to install on hardware, it's like if you install Eve, the point is that's the one stack you need, and if you want to use some stack that you qualified, or Debian or Ubuntu or Windows or whatever, great, you run it on top, but you have one consistent abstraction layer. And then again, of course, that open API. So there's a lot more information on the site in addition to what we'll talk about today. Next slide. Okay, so at the IoT edge, why is Eve important as a kind of a foundation? At that software infrastructure layer above the hardware, it's a bare metal solution. You can also run it in VMs, but think of it as a bare metal abstraction layer. So core reasons: number one, very, very, very diverse set of technologies and domain expertise required. At the IoT edge. I mean, the closer you get to the physical world, again, things inherently get more complex. You need hardware that's got specific I/O, it's ruggedized, very specific certs. It could be class 1 div 2 if you're out in an area that there's potential for explosion due to chemicals or whatnot. There's a sea hardware types, but so because of that, it'd be great to abstract as much as you can from the hardware in terms of software, so that you have the same software that you can deploy regardless of the underlying hardware. And the same goes for domain expertise. If you've got various different people that know different things about a certain market, you want to be able to bring those people together on top of infrastructure that supports these tools and their knowledge to come together in a more loosely coupled way. This is why you want to extend cloud native principles as close to possible, while recognizing some inherent trade-offs. Actually, the white paper goes to tell about those trade-offs, and it drives why the categories are what they are across that continuum. The scale factor. To the physical world, you're going to see more and more scale in terms of devices. It's tens of thousands in the centralized data center, kind of up in the cloud, so to speak, to the eventually trillions of constrained devices at the edge, in the physical world, and then IoT edge is somewhere in between that. Lots of devices, highly distributed, again, outside of secure data centers. So fully accessible to semi-accessible locations. One has no perimeters, so that's that data center component. I'm not locked up in a data center. Someone could walk up to it and try to stick a USB key into it and load some malware, or just otherwise take over the device. Before, you might not have a network perimeter at all. You don't have you can't rely on a firewall. Someone else owns the network. So because of that, Eve is important in terms of driving a zero trust security model, combined with the stuff that you build on top. Zero trust means you trust nobody, and then on the network or users, no device or user, and then based on a set of layered criteria, you start to kind of open up and communicate. And so there's a lot of functions within Eve that enable that based on root of trust. So the hardware-based root of trust, if available. And so the net is, for all this, you need a foundation that's kind of open, consistent, flexible, and agnostic to different stuff that's out there. So you kind of have a one-stop shop, and then you take your pick of stuff on top. Next slide. Like I said, again, think of it as what Android did for mobile, we want to go do for the IoT edge, and kind of different tool sets, different use cases. Mobile devices are tend to be more about download. IoT devices tend to be more about upload. Of course, you've got different application sets and whatnot. All the considerations are slightly different, but the principles are the same, and the goal of having an open stack is the same. Next slide. Okay, so here's a comparison of some different choices that we see architecturally out in the field, and Roman again will get into a lot more detail, on what we're doing with Eve. But if you compare what Eve is, which is this bare metal foundation, completely open, 100% open APIs, and the kicker there is that it's vendor neutral governance, driven through the Linux Foundation with LF Edge. There's other open source management and orchestration platforms, but they don't have that governance. So then you're kind of at the whim of the community. You don't have that structure. So that's why LF Edge, we think, is important. Why we think it's great that the community's doing the work there. It supports containers and VMs. We'll talk through that more. So you can use your legacy investments in VMs, or even whatever you want. You can deploy stuff in VMs if that works for you, alongside containers. And we'll also talk about the bridge that we're going to build to Kubernetes. Because it's bare metal, there's no risk of breaking during updates. It's at the lowest level of the hardware. It also has access to things like the ports, and so you can turn on and off ports to prevent people from tampering with the device remotely. You can do things like distributed firewall, and Roman will talk about that a bit, including. And it's optimized for devices at the IoT edge. I mean, there's lots and lots of stuff for data center equipment and virtualization and all that, but you cannot run that stuff on highly constrained devices. But also, they're not designed for the security needs necessarily outside of a physically secure data center. Plus, a lot of the data center tools kind of assume that there's a constant connection to that device, whereas Eve has an eventual consistency model, which basically says you set the state that you want it at, and whenever it has connection, it will continuously try to update the applications on top, including itself, until it meets that need. So comparing Eve to some other approaches, so there's definitely proprietary solutions out there. You can, if you get bare metal, you can do similar things around security and networking and benefits, and not be resilient during updates, so you don't get breaking of devices. But the customer, as the user, you're locked into that controller, that proprietary controller, and that's not good for the variety of the reasons that we've been talking about. The solutions that are out there that are focused on the IoT edge, not traditional data center compute, they tend to support either containers or VMs, not both. And then there's also that whole factor of data center solutions are not really designed to be at this particular. The last one is there's a category of open source or proprietary agent-based solutions where you're running an agent that sits on top of an OS, and that agent kind of orchestrates in concert with whatever backend controller you're using, whether it's in the cloud or on-prem. If you don't harden the agent together with a particular OS and invest in that integration, which is basically then turning it into Eve, what happens is that you get security gaps. And quite And you could also run this risk of breaking that device because you have that integration down to the hardware, and then you're driving a truck out to go fix it. Most of the solutions, the agent-based solutions, they only support containers, which is obviously, containers are taking the world by storm, and so is Kubernetes. But virtual machines help you get to that legacy support that is very important at all edges, including industrial use cases, of course, at the IoT edge. The proprietary variants, same problem, lock in. But I would mention that the open source variants, are actually complementary to Eve, because you could put that agent, tie that into the APIs within Eve, and get those benefits on the tail end. So, and we're collaborating. We're looking at collaborating with some other projects in that front. So, it's not an either or in that sense. Next slide. Eve is a horizontal solution. You won't go through all the details here, but you can support any vertical, any use case, containers, VMs, all the benefits that Roman will talk through. But workload consolidation is a common one where I'm taking maybe a legacy SCADA app from an industrial, running that on hardware out on the factory floor right next to maybe a modern app like an AI model that I push down. For inferencing, and any number of workloads or containers. You don't have to get rid of the things that you already have, but you can innovate with cloud native principles in parallel. We've seen people using it as a agent for kind of a network proxy, like a router almost, like out in the field. There's Eve is actually installed on some hardware inside of wind turbines today. There's a customer out there using it for that function, and it's all about, in that case, running an app to make sure that their data is routed securely back to their central data centers. And then the last one it's kind of similar to the workload consolidation one, but in this case, you're running stuff out of band. You put a span port on hardware. You could be running a security app or some sort of analytics app on top, out of band from all the other main data flow. And getting insights across your network. So we see like some people are building security appliances that are using Eve as the mechanism to update the app that sits on top as those devices are deployed out on networks. So lots of different use cases, of course, in various verticals. These are the horizontal ones. So with that, I think next slide, I think I'll hand it over to Roman. Yeah, Roman, if you want to talk through all the
yeah, absolutely. Here. So I think, from now on, we will be deep diving into the Eve implementation itself. So thank you, Jason, for setting up the stage for, what verticals Eve is applicable to, and, why is it interesting to talk about it in the first place. So let's deep dive a little bit and just talk about Eve, itself. So Eve, you could think of it as an operating system or a hypervisor, but a hypervisor not in the sense of a standalone component, but rather in the sense that ESX from VMware or Xen server, from Citrix is a hypervisor, right? It's an entire layer that could be compared to an operating system that gets deployed on a piece of hardware. And once you deploy it, you don't actually have any other operating system running on bare metal, right? You have just Eve, and everything else runs on top of Eve. Now, before we actually start talking about Eve components and what gets used to orchestrate all of the functionality, let us just spend a bit of time differentiating between different type of hypervisors. And maybe Stefano, who actually was the author of Xen on ARM, can help us understand the difference between type 1 and type 2 hypervisors and how Eve sort of uses both.
Yeah, thanks, Roman. So there are many hypervisor architectures, but roughly we can categorize them into different groups, type 1 and type 2, and they help us understand how they work and how the software is architected. So type 2 hypervisors are hypervisors like VMware workstations, Parallels, something you install on your, or KVM, something you install on your regular operating system, and now you enhance your operating system to start VMs. while type 1 hypervisors are like ESX from VMware and Zen, that are smaller typically, and they run at a higher privilege level than everybody else in the system. So they tend to be completely separate from any one operating system. Now, the two architecture have pros and cons, and for instance, it's difficult to beat the ease of use of double clicking on your VMware Workstation installer on your Windows laptop, for instance. On the other hand, with type 1 hypervisors, you can they allow for highly isolated and highly secure and disaggregated architecture, because it's a smaller separate component, so you can use it to run, for instance, specific drivers in separate VMs, run PV frontend and backend in different VMs. So very sophisticated and more complex architectures that allow for a large chunk of code to run in non-privileged mode, would be the equivalent of not running as an administrator or as a root your application in your operating system. This is what basically a type 1 hypervisor allows you to do, run large chunk of code, even driver stacks, in non-privileged mode.
Yeah, thank you. And with all that choice available, I mean, to Stefano's point, I think what becomes a very interesting value proposition for Eve is that we're trying to stay hypervisor agnostic, even though we started with Zen, and we're still very much in love with type 1 hypervisors. But we're trying to stay hypervisor agnostic to bring that ease of use, as Stefano was talking about, to the end user. So the end user doesn't really have to really know all of the details of the implementation. Now, you still get slightly different characteristics between running, let's say, a KVM-based Eve or Zen-based Eve or even Acorn-based Eve. But all of the implementation details are hidden from you. And they're hidden because Eve consists of all, these fundamental building blocks that we will be discussing shortly that orchestrate all of the other components that run on the bare metal. So these building blocks basically include a building block that essentially interfaces with the hypervisor, be it Zen, KVM, or Acorn. We call it a domain manager. A building block that basically takes care of the root of trust, any kind of trust element in the Eve, right? Identity manager, so identity of the box gets handled, through the same one. There is a building block that is responsible for verifying all of the incoming material that comes to Eve. So for example, if Eve needs to run a container, because Eve runs containers and virtual machines, that image of a container or virtual machine will have to be downloaded from the internet. The root of that trust is basically being verified by the verifier, right? Then there is a few other components, like the component that is in charge of setting up proper networking. There's a component that is in charge of basically setting up the specific drivers, for different types of the hardware that you may have it, attached to your box. And altogether, all of these components, they're actually written in a microservices style architecture, even though typically you would hear about microservices in the context of web applications and public cloud. Eve itself is implemented in Go, language called Go. And all of these individual components are implemented as individual microservices. Why is this important? Is because we can provide a much higher isolation for the microservices-based architecture to a point where with type 1 hypervisor like Zen, we can actually run every single individual microservice in its own virtual machine, which protects the rest of the system and isolates the microservice down to just the functionality that it needs. Next slide, please. So just to summarize the key capabilities of Eve, Eve really tries very hard, to be the Android-like experience for its users, in the sense that it tries to give you a really easy to use capabilities that otherwise you would have to configure and manage yourself. Just to give you an analogy, same way that Android doesn't make you think about what device driver for a camera you need to install, or what device driver for an LTE modem you need to use. It just gives you those capabilities. Eve gives you a bunch of capabilities that I would just quickly go through. So one of them is very easy way of interfacing with trusted elements in the hardware. So we are typically using TPM technology on Intel, and we're looking into things like T on ARM. But all of those building blocks actually have to be orchestrated quite a bit. And if you Google, setting up TPM or setting up T, you will see how complex it is. Eve actually tries to abstract all of that complexity away. As Jason was pointing out, trust is very important in systems like that. So Eve tries to be secure by default, which means that, if you have a default installation of Eve that comes obviously from the open source project, so you can inspect all of the source code, we try to come up with pretty reasonable defaults for the security profile. Pretty efficient with use of resources for CPUs, memory, and networking, and all of the user level workloads basically get expressed as what we call edge containers. Now, edge container could be just a general Docker container or OCI container. You can just point at a registry, let's say Docker Hub or Microsoft registry, and download a container from the registry or a series of containers and run it on Eve. But you can also package your virtual machines inside the containers, and that's why we invented this separate term called edge containers to give a bit of an indication that these are containers that have been enhanced for additional use cases. So because you can put just about anything inside of that edge container, right? You can host any kind of operating systems. And a lot of our customers, for example, today use Eve to run legacy workloads that are hosted on Windows. So we just take that Windows as a whole, operating system and run it on Eve. On the other end of the spectrum, we're very excited about serverless capability and unikernels. And serverless means that you take the smallest piece of your business logic, right? You turn it into a standalone component that doesn't require even an operating system, right? You give it to Eve, that becomes a unikernel, and Eve runs it just as a virtual machine, but it's a tiny virtual machine compared to that other extreme, which is running a full-fledged Windows VM. We have an ability to assign, CPU and GPU cores to specific apps. Obviously, an ability to very specifically assign different types of I/O. Networking I/O, industrial I/O to different types of applications. And we actually give you an ability to update the entire Eve stack itself, the same way that you would update an application. So everything gets managed through the cloud. I mean, there are absolutely no notion of usernames, or passwords on the system, right? Interacting with Eve is only possible through the controller, and interacting with the controller feels a lot like interacting with any other public cloud, right? You just ask it to run VMs or, set up networking or set up security zones, and it just does it for you. And speaking of the security zones and networking, Eve comes with a distributed firewall and also mesh, SD-WAN type of a networking component. We're actually using Lisp, a technology that has nothing to do with the language and everything to do with an internet RFC. You could look it up, but it basically gives us a very open, transparent way of setting up secure mesh networks for different Eve instances and applications that run on Eve. Next slide, please. So that's what's already in the project. I mean, some of those capabilities are more developed than others, but they're all in some way present in the project. What we're looking for to do in Eve for the rest of the year is basically increase modularity of the architecture itself. We would love for Eve, I mentioned that Eve, even today, is based on the microservices-like architecture, but it's pretty tightly sort of packaged together. They're not tightly coupled, but when it comes to packaging, they're packaged in a footprint that is basically an operating system in and of itself. We would love to break that apart and essentially allow you to run individual components of Eve, as Docker containers. It can be useful for testing. It can be useful in constrained environments. There is a number of use cases where it may actually come very handy. With that, you will see us sort of playing more and more with technologies like Docker Compose. And Docker Compose is obviously helpful because it's an ideal way to manage a series of containers, even edge containers, what we are trying to do on a single node. I mean, you typically wouldn't use Docker Compose to run a distributed application. That's where Kubernetes, especially K3s, you know, with its small footprint comes in. And that's also something that we're taking a very serious look at in terms of integrating it directly into Eve. So that when you install Eve, you not only have those capabilities that I described on the previous slide, but you basically have built-in Kubernetes capabilities without even installing anything but Eve itself. As I mentioned, you know, we are trying to stay hypervisor agnostic, and to prove it to you, we already support 3 different hypervisors. Zen, this is our baseline. That's what we started with. You know, we integrated KVM recently, and by the way, integrating KVM, we did, you know, in a way that I really like. We actually completely cut the libvirt you know, component that typically gets used when integrating KVM, because that brings a lot of bloat and unnecessary size, you know, expansion of the image. So we're actually doing direct integration with KVM, which allows us to keep Eve image very small. And we're actually integrating with Acorn, you know, type 1 hypervisor available from Linux Foundation itself. It was originally created by Intel, you know, for industrial use cases. But has since then been donated to Linux Foundation, is now just a sister project to Eve. We're actually looking at mesh networking capabilities that would go beyond Lisp for the edge-to-edge data flow use cases. And we're particularly excited about WireGuard technology that has recently been integrated into the Linux kernel. And there's a number of companies that are now trying to productize and sort of bring it to market. So we're working with a couple of those companies to see what capabilities can be integrated directly into the open source core versus what capabilities may actually remain to be more of a proprietary type of extension. But just like we're investing in you know, being hypervisor agnostic, you will see us becoming more and more network agnostic. So Lisp will probably still stay and be one of the options, but we would love to expand that array of options for the networking, and especially when it comes to SD-WAN type of capabilities. So we continue to shrink the Eve runtime, right? You know, I saw a couple of questions about whether it would ever be possible to run Eve on super constrained devices, like something that, you know, you would use a real-time operating system today. And the answer to that is unlikely. I think Eve, to Jason's point, will always stay sort of slightly above the MCU level, but it doesn't mean that we wouldn't be shrinking down the footprint. And I think if we can go down to like 128 megabytes maybe for some of those type of use cases, that would be great news for everybody. Next slide, please. So just to give you a little bit more of a user-centric view, right? You know, and that comes back to the simplification of the Eve architecture. Let me just focus you on 4 concepts that as a user of Eve, you will be thinking about, right? At the end of the day, even though you interact with Eve through a controller, what you ask controller to manage on every single Eve instance, because obviously a single controller may be managing thousands of, you know, instances of Eve. On every instance of Eve, you're essentially managing 4 types of things, right? So you are managing tasks, and task is a runnable entity, right? It's something that consumes your memory and CPU. It's something that runs on a machine, right? Runs on a system. Task on the left, task number 1 is just unisolated, right? You know, imagine a Docker container or even a Unix process, that could be a task. Task on the right, you know, task number 2 is actually isolated within the hypervisor. So the hypervisor is helping to make sure that task number 2 can never really interact with the rest of the system, you know, unless allowed, right? And the system cannot really affect the task. So tasks always are runnable entities, but they can either be unisolated or they can be isolated with the help of the hypervisor. That's basically what's happening on the running side of things. Then what do you actually need to run those tasks? Well, obviously you need some kind of a local caching, you know, storage, and that gets implemented through the concept of volumes. That's a concept number 2 that you would have to think about when you're managing different things on individual Eve instances. So tasks may have different types of volumes associated with them. Some of the volumes will provide root file system, right? You know, it would be like a disk, you know, that you would boot your VM from, or it may be a root file system for a Docker container. It still would be a volume. You would still express it as a volume. And a single task can have access to different volumes. So for example, in this picture, you see task number 1 and task number 2 sharing volume 1 as a root file system. So those tasks, for example, could be, one of them could be, again, a Docker container. The other one could be a virtual machine. They would still share the same root file system. But as you can see, task number 2 also uses volume number 3 as an additional file system, or maybe a block instance, because volumes can be block instances as well. So you can have multiple ways of hooking up volumes to running tasks. And finally, tasks can be attached to networks. So network is a very abstract entity number 3 that you would have to think about when you're managing, your individual Eve instances through a controller. Networks allow tasks to communicate with each other, using basically packet flow. We provide ability to instantiate networks that allow you L2 plus and L3 plus network flow. So basically from the level of IP up and from the level of something like TCP up. But networks also allow tasks to be connected to external entities, right? Like different instances of Eve, or, public clouds, or your corporate IT networks. So that is an abstract notion that you will be managing on an Eve instance, and just giving, attaching tasks to networks to allow them to communicate. So these are the 3 notions, right? Tasks, volumes, and networks. But I promised there would be a 4th one. And the 4th one is actually a special case of volumes. It's called secrets. It's so secret that it's not even on this slide, but it's just a separate kind of a volume. So with that in mind, it actually becomes pretty easy to sort of have a mental model of what you ask a controller to do. You essentially give controller instructions to instantiate these types of objects on an array of Eve instances under your management. And then, something useful happens. That's basically Eve in a nutshell. Next slide, please. So one of the most exciting, developments as of, a few past months ago, and a lot of credit goes to Stefano, for helping us get through this, is we've been always supporting ARM, but before we kind of were constrained by, the type of a board that we had to use. So Stefano, when we started, recommended to us Hikey board, for running Zen. Because it was one of the most, inexpensive boards, for people to use. But with an introduction of Raspberry Pi 4, we finally get a really mainstream ARM board, for any type of hypervisor hacking, which is exactly what Eve needs, right? So Raspberry Pi 4 can support KVM, it can support Zen, and it's actually a very nice extensible system that we're very excited to bring to the table and sort of make it available to all of the hackers. I got mine, a few months ago, started the port. It was pretty easy. Stefano got his, a few weeks ago, and again, it's now helping us with Zen, actually discovering a few issues even with Linux kernel along the way. So, that's goes both ways, working on this project, not just helps Eve, but helps, Linux Foundation in general. We're actually, trying to make sure that it would be as easy as just clicking a single button and getting your board, to start playing with Eve. So stay tuned for the Eve in the market page, for different controller options. So you don't have to, build your open source controller. You can just hook it up to a commercial controller, with a single click of a button. And check out, this URL for the Raspberry Pi 4 support. More will be coming. So there is an image, you can follow instructions, order your Raspberry Pi 4 and just, let us know how it goes. By the way, there is a LF Edge Slack channel that you can all go to. And there's obviously Eve specific, sort of sub-channels, I guess that's what you call them in Slack. So if anything is not quite according to the documentation, you can always tell us, what's working, what's not working on the Slack, or send us an email. Either way is fine. One of the exciting parts about Pi is obviously that if we can make Zen sort of be super compatible with Pi, I think it would actually increase the amount of ARM hackers, for the Zen community as well. And Stefano, I don't know. I mean, what's your opinion about how difficult would it be to support Raspberry Pi compared to Hikey?
No, we are really close. We are basically already there. So so the Raspberry Pi is an extremely popular platform, as you all know, and they even have a brick and mortar store now in Cambridge, UK. I've been told.
Exactly.
So one of the issues with Raspberry Pi though is for a long time it had a bunch of uh, uncommon esoteric devices, in particular the interrupt controller, that will make it very difficult to run an hypervisor on top. But what people might not be aware is that actually Raspberry Pi have been getting consistently better each revision, and Raspberry Pi 4 is really, really good. So it comes with a quad-core S72 processor. It's quite powerful. There are 4 GB version of the Raspberry Pi 4. And more interestingly, it has a standard interrupt controller. So now it's fine to run really any hypervisor on the Raspberry Pi 4, including Zen. So I was very optimistic, and I thought it would work out of the box. You know, sometimes we software developers tend to be overly optimistic about things. So in reality, it took us a bit of effort to work with Roman, the Ape community, and the Zen community to get it done. So the first issue we found is that the Raspberry Pi, actually many devices on the Raspberry Pi require memory to be within the first gigabyte to operate. You know, with an hypervisor, when you run a type 1 hypervisor, your VM believes that the memory is under 1 gigabyte, but in reality it could be anywhere because it's virtualized by the hypervisor. So that was the first bug. It was fixed by Julian Grau, one of the other Xen maintainers. And that actually get an overwhelming positive response from the community. So we got 2 or 3 people that jumped off, I mean, never heard of them, and, you know, on the mailing list said, yeah, I tried it and now it works. You know, that was fantastic. That just tell you how popular the Raspberry Pi is, really. More to that, then Roman rightfully went on to try more recent kernels. So these guys were trying a more, I think a 419, an older kernel. So we tried bleeding edge, we tried master, and we found more issues. So now I have a patch series on the list that solves a generic problem. I don't know how interested you guys are on details, but on hypervisor and kernel details. But turns out, you know, that on some platforms, the DMA addresses that are the address in memory as seen from the device differ from physical addresses. Now, these platforms are kind of, I mean, uncommon. Like, they're typically mixed PowerPC, but this is the very first ARM platform that I see with this issue. x86 doesn't have this either. So we had to adapt some of the Linux kernel code that interact with Zen stuff to deal with these different offset and addresses. You know, to the benefit of all platforms, really, because this is something which we should have done long ago. So now we have Zen Linux, you know, the very latest Linux, very latest Zen, booting just fine on Raspberry Pi 4. So it's a great platform for hacking. And Roman, I think you have you know about EVE images with Zen for Raspberry Pi 4, right?
Exactly, yeah. So if you go to the link, you know, at the bottom of the slide, you can actually follow instructions and download the ready-made, you know, images off of our Docker Hub. So we kind of like, you know, a lot of people joke that, you know, we're not really true embedded developers because we use Docker for just about everything. I mean, a true embedded developer would have used something like, I don't know, maybe Yocto Linux. But yeah, we use Docker for everything. So even the EVE images itself actually get packaged in Docker containers, which makes it, you know, pretty easy for anybody with any kind of laptop, even Windows, you know, to try things out these days. So yeah, so that's Raspberry Pi for you. We would be super excited if you could join us on this journey and, you know, start looking into different types of IO devices that can be attached to a Raspberry Pi, you know, share projects with us that you may be doing, you know, with the help of EVE, and just share your general experience with how Raspberry Pi goes. So with that, I'll give it back to Jason, you know, to wrap it up and, you know, give us a few community updates.
Cool. Yeah, thanks, Roman and Stefano. Next slide. So yeah, quick on the community. So we contributed EVE into LF-Edge. It was one of the founding projects when LF-Edge launched early last year. And so a lot of us at ZEDEDA contribute, but then also we've been seeing a lot of contributions starting to come in from the broader community. Of course, Stefano with Xilinx. We've had some contributions from Intel around Acorn, and we're talking with Intel about their secure device onboarding effort, which is a really great effort that helps with zero-touch provisioning within the channel. We're talking, we've got contributions coming in from a number of others, and you can see the curve on the right there. EVE is deployed in several vertical markets. Again, it's horizontal in nature, but certainly targeted at the IoT edge. And we're always working to collaborate with other industry projects, whether it's within LF-Edge or otherwise. And if you go to the next slide, we've got some examples there. Another slide, but this is good. So from a in the market standpoint, of course, from a commercialization standpoint, the project, of course, open source, but one of the pages within the site talks about the various different models of hardware out there that we've worked in the community to qualify on. That list will be ever growing. Of course, we just added the Raspberry Pi, as the guys talked about. But the point here, as I mentioned early on, is if you install Eve on your hardware leaving the factory, is the best place to do it. You can install it at any time, of course. The moment that box touches a network, it will phone home to your controller of choice and get the everything updated and downloaded, and then you can kind of take the life cycle over from there. So it really simplifies your supply chain. Kind of the one stack, again, do for IoT what Android did for mobile. And then you take your pick of value add, including operating systems if you want to host specific operating system within the VM, and you get all the benefits that the guys talked through in terms of networking, distributed firewall, zero trust provisioning, root of trust, all that. And then there on that same page, there's some links to various different controller options, and we expect that to grow over time. Next slide. The last thing, and I know we've been answering questions as we go. But if there's any last questions, you feel free to chime in with those in the chat window or the Q&A box. And within LF-Edge, we're of course collaborating with EdgeX Foundry and Fledge, as application frameworks, totally complementary there. And we're working with a variety of different other application frameworks, Azure IoT Edge and Greengrass and others that mentioned. As Roman mentioned, the bridge here to Kubernetes and K3S in particular is important. Think of it as like the data center innovations are kind of moving down towards the edge with K3S. Rancher's been doing great work leading that charge. Eve is rooted in start at the IoT edge with those unique challenges that we talked about, including supporting virtual machines for legacy, and then grow that up into meeting the vector coming down from the data center. And so that's that work that's happening now as we're starting to kind of evolve the footprint, as Roman talked about. Let's meet in the middle, but we still have those considerations IoT edge in play. Crano within LF-Edge, we've been working with, building out an industrial IoT edge blueprint. Aaron Williams, who's a community lead, has been doing great work there, under LF-Edge or in Linux Foundation, working with the teams. IBM Open Horizon recently came in to LF-Edge as a stage 1 project. And so we've been talking with those folks around, does it make sense to bridge that agent-based solution to Eve as a foundation so you get those benefits? That's kind of like it's that concept that I mentioned in the different architectural approaches, is that they're actually complementary when you consider it that way, in that sense. I mentioned Intel's secure device onboarding effort. So we're working with them on that. That's a really, I think, important effort for the industry, and Intel's actually collaborating with ARM on that one. So we tie all these things together over time. Intel also helped launch something called the Open Retail Initiative last year, and the code for that is rooted in EdgeX Foundry. And it's basically a coalition of the willing, so to speak, of companies that believe in using open source and collaboration in that arena to help boost up retailers' ability to stay competitive and focus on innovation versus reinvention. And so the ORI is, I think, a really important effort, and we've been talking with them about how Eve can help. A great example of where workload consolidation in retail, I need to run a legacy point of sale system right next to a container-based workload. So Intel, HP has been very active there, a bunch of other companies, so really good stuff happening there. IBM just joined in, so lots of good names. And then the last one I'll mention, it's all about trust. We talked about trust earlier, and there's projects kind of spinning up in the industry. Of course, there's things like blockchain and all that, but there's like a system level approaches starting to kick in. And recently within Linux Foundation, there was a trust over IP initiative announced. There's a project that I've been involved in with a variety of others called Avarium that we're looking at spinning up around kind of building these data confidence fabrics. And those types of projects over time make a lot of sense to have a link to Eve as that sort of baseline foundation, of course, in a very open model, but using technology to help build intrinsic trust into systems. So with that, I saw some other questions going. I think the next slide, I think we just kind of wrap it up. You know, a lot of the links here, you'll get this presentation, and of course, just go to the EVE website. All of the meetings are open is in true Linux Foundation form. The best way to get involved is just get involved and contribute and whatnot. But we certainly welcome it, and of course, there's the commercial aspects as well. Jill, I'll turn it back to you.
Great, thank you, Jason. Thank you, Roman. Thank you, Stefano. This was a great presentation. We appreciate your time and your insights here. It does look like most of the questions were answered. I've got one here, one open question here in the Q&A. Very basic question: if my EVE device is behind a firewall, what ports, if any, need to be opened to communicate with the EVE controller? Is there any scenario whereby inbound ports need to be open?
So let me take this. No, there's absolutely no need to open inbound ports. I mean, that's what makes EVE so suitable for IoT use case. EVE only ever calls you. I mean, you never really have to call EVE. In terms of the ports that you would have to open for the EVE to call the controller, because remember, you can actually run the controller, outside of your enterprise, right? You can run it in the cloud, or essentially on the public internet. EVE communicates with the controller using MTLS, mutual TLS, right? So that would be the standard, port for that. We actually have ways of communicating between controller and EVE that doesn't even include MTLS, but that's a bit of a new development and more esoteric combination. For the majority of the use cases, just think about, communicating with a secure HTTPS, server, and that's basically what EVE would need out of the controller to successfully communicate with it.
Great, thank you. So it doesn't look like we have any other questions, and we are just about out of time anyway. So I would like to wrap things up. Thank you everyone for your participation. Thanks to our attendees. As we've mentioned, the slides and the on-demand recording of this will be available after the fact. We'll have it up tomorrow. So thank you everyone for joining us, and please join us again for another On the Edge with LF Edge webinar.
Thank you.